All right, so this is the USACO problem to January 2019 IC perimeter. As you can see, I have already full green this problem, so I do know what I'm doing. Unlike the other ones where it is just a blindfold walkthrough. But this one is an interesting application of depth first search. So let's get straight into the problem. Farmer John is going into the ice cream business and he has built a machine that produces blobs of ice cream, but unfortunately in somewhat irregular shapes. And he is hoping to optimize the machine to make the shapes produced as output more reasonable. The configuration of ice cream output by the machine can be described using an n by n grid as follows. Each that is a dot character represents an empty space, and each hash character represents a one by one square cell of ice cream. Unfortunately, the machine isn't working very well at the moment and might produce multiple disconnected blobs of ice cream. The figure above has two. A blob of ice cream is connected we know how it is connected. Just quickly, the adjacency is north, south, east, and west. Farmer John would like to find the area and the perimeter of the blob of ice cream having the largest area. The area of a blob is just the number of hash characters, and the perimeter is the perimeter. So in the above example, it's 13 and 22. Note that a blob could have a hole in the middle of it, empty space surrounded by ice cream. If so, the boundary with the hole also counts towards the perimeter of the blob. Blobs can also appear nested within other blobs, in which case they are treated as separate blobs. For example, this case has a blob of area 1 nested within a blob of area 16. So right here we can see the blob of area 16 is this kind of outer one that flows right up here. And just quickly checking, this has a perimeter of 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then 20 plus 12 is 32. So this has a perimeter of 32, and this one has a perimeter of 4. So knowing both the area and perimeter of a blob of ice cream is important since Farmer John ultimately wants to minimize the ratio of perimeter to area, a quantity he calls icy perimetric measure of his ice cream. When this ratio is too small, the ice cream melts slower since it has less surface area relative to the mass. Input format. For the first line of input contains n, and the next n lines describe the output of the machine. At least one hash character will be present. The output format is a line containing two space-separated integers. The first is the area of the blob, and the second being the perimeter. And it's the area of the largest blob, and the second being the perimeter of that same blob. If multiple blobs have the largest area, print whichever one has the smallest perimeter. And that's again to minimize the IC parametric measure. And the sample input they've given here, we can quickly read over it, but let's not do that because that is a little bit boring. So here we're gonna switch to this. This is not an empty one per se. This is not an empty project by any means. I've actually set up everything so we get our inputs right off the bat. These you actually don't need to worry about for now. We'll explain them later. But this is just taking in all of our inputs. So here's how we're going to be solving this problem. So going back here, what we're going to do is we're actually going to DFS through each blob. So we're just linearly going to go through this and DFS. And basically, if a space has not been visited already, and it's also a hashtag, which we're going to represent with a 1 since it's simpler, then we're going to DFS in through that. And basically, we're going to create a temp area and a temp perimeter and just continually increase those through our DFS. And at the end of the DFS, when we're finally hitting our last return, we'll check those area and perimeter against the ones we currently have and update the maximums. So that's the strategy, and as we code it, it'll make a little more sense. So the first thing we're going to need is we're going to need a static int array visited, and this is actually going to be a boolean array boolean, and this is just our visited array. We're also going to need a static int area, and this is going to be our final maximum area, and static int peri, and this is going to be the perimeter, and static int tier, basically the temp area. I'm using 4 letters because it's easier to do that, and static int t perimeter, and this is t pair. And so these are the things we're going to use. Quickly, just briefing over this, I have a buffered reader and a print writer, a string tokenizer, taking in our value of n, creating the board to be size n plus 2, n plus 2. And that's just so we have this space on the outside of our board. So if I were to quickly just draw this, let me switch to here. So if I were to quickly draw this, our board would look something like this, and this would be more of like a grid, you can think. And what we would have is we would create this just space outside of the board, and that way we can just check this, and let me do this in a proper color. We can, if we're checking a square like this, we can also check these squares. And basically, it just it's a common thing you'll do. You'll provide that extra layer of buffer, so that way you don't have to check if it's also a boundary case. Yeah, it just makes it a whole lot simpler. You don't have to check a boundary case. So what we'll then do is we'll just take in our inputs. So for I equals 1, I less than n plus 1, we're creating the line as the next token, and we're getting the character at j minus 1, and we're checking if it is equal to a dot, then mark it as a 0, otherwise mark it as a 1. And this is a ternary operator, basically. So what we're then going to do is create a DFS function. So public static void DFS int I and j. And these are the coordinates. So step 1 is to say visited of I of j is equal to true. And if a board of I minus 1 of j is equal to a 1, then there is a space there, and so that would not count to the perimeter, right? And then what we would want to do is we would want to check if it's not visited of I minus 1 of j, then we would want to DFS into that visited of I minus 1 of j. And actually, we wouldn't want to visit it. We would want to just I minus 1 j. And the last thing we do is we'd say t area t air plus plus. And that's just incrementing the area by 1. And so we'll start this off at 0, we'll start this off at 0, we'll start this off at 0, and we'll start this off at 0. Now, on the condition that it is not a 1 there, that means we have a perimeter. So else, then we've got a t pair plus plus. And this is kind of the logic we'll just use the entire way. And so here, it's not that, it's a plus. And here, we're changing the j. And these are just the edges. Make sure you understand we're just checking the different edges, which is our adjacency. And finally, we'll change this to plus. And so here's why we created the board as size of n plus 2, because now we don't have to also make sure that the I value is of a specific thing, etc. And that's pretty much it. So what we would now do is we'd want to say for I equals 1 I less than n plus 1, and a for I equals, for j equals 1 j less than n plus 1, we want to say if not visited of I of j, dfs of I comma j, and then we'd want to check if um, area is equal to t air, and perimeter, the original perimeter is greater than t pair, then the perimeter is equal to t pair. And then else if area is greater than t air, and then we want to say perimeter, then we want to say area is equal to t air and perimeter is equal to t pair. And so then what we'd want to do is we would want to so this is basically just our maximum checks. This one is handling the if the two areas are the same, then choose the smallest one, and this one is just simply handling if the area is greater, then change this accordingly. And finally, we want to pw.println of, we'd want to print out the area plus a space plus the perimeter. And we want to close, pw.close. And that's it. And now we can open up the terminal and Java compile perimeter.java and Java perimeter, and we'll check our perimeter.out, and we have a null pointer exception at 27. And that's because we haven't initialized our visit array. So viz is new Boolean array of size n plus 2 of size n plus 2. And so now perimeter.out is initialized to 0, 0. So if it's not visited, where are we going wrong here? So what we'd want to actually do here is say tear is equal to 0 and t pair is equal to 0, but tear must be greater than area here. These are the two things that we were missing. Now it should give us the right 1632. Great. And that's for, oh, I closed that out. That's for this input, which is the circle, like we calculated by hand. And if we do take their sample input, then it's going to give us 1425. That is wrong. So it should be 1322. So it's somehow counting an extra one. Um, Why would it be counting an extra one? So if the area is equal to the T area and the current perimeter is greater than our T perimeter, then set the current perimeter to our T perimeter. And otherwise, if our current area is less than the temporary area, set the area to the temporary area and the perimeter to the temporary perimeter. So I don't see exactly where we are going wrong here. Okay, so I did a bit of debugging, put in some print statements here, and I realized we also have to check that the board of I of j is equal to 1. And basically, I just added print statements here to check what I and j values it was going to. So now it should work. Yeah, 13 and 22. Great. So that was a simple problem which had a quick fix. So let's submit it here. And submit this. And hopefully we get everything correct. And boom. The last one timed out. How interesting. Why would that happen? Hmm. Okay. Very weird. I just resubmitted and it worked. I'm gonna try it again. Um, yeah, okay. I'm not entirely sure what happened or why that happened, but it might have just been a server-side issue. Anyways, this was IC Perimeter from USACO 2019 January Contest Silver. And here is my code again, if any of you guys want to see. And it's quite simple. Here's the, firstly, here is the static variables I've used, my main function, and my DFS function. If you guys did enjoy, please don't forget to like and subscribe, and I will catch you all in another video.